Welcome to Math Master. This is Saritha. Today we are going to continue the topic of arc. In the previous video, we have discussed some of the properties of arc. We will continue those properties. See what was the last point about the arc? That is the arc AB means this arc subtended an angle at the center is twice the angle subtended at any other part of the circle. Yes, this we have seen in the last property. So, the same case we have seen that with the minor arc, right? So, we have considered AB arc and we have seen that the previous case. So, now the same case we will see now with the major arc. See, we always whenever we see the circle, we observe always with the smaller arc. But sometimes there is a case which we will get with the major arc also. So that we have to see now. Okay. So if we consider an P here, so this is APB arc, isn't it? So this APB arc makes an angle at the center. So what is that angle? This is the angle. This APB, this total arc makes an angle at the center is this one, which is nothing but alpha. Okay. So, and same arc, this APB arc makes an angle, means this APB arc subtend an angle at any other part of the circle, right? So, this is the arc and this is other part of the circle. So, here this major arc makes an angle, right? So, that we will see. So, this is any point on the other part of the circle. So, this is the angle this major arc makes at any other part of the circle. Okay. So, what is the relation? Any arc. The angle subtended by an arc at the center is always twice the angle subtended by the same arc at any other part of the circle. Right. So, the same property follows, but we have seen the first case with the minor arc. So, the second case with the major arc. See, if this is alpha, this is twice the angle of this, isn't it? If this is theta, what happens the alpha value? This is 2 theta, isn't it? Yes, this is the angle subtended at the center. This is the angle subtended at any other part of the circle. Okay, so we have seen the same relation also applies with the major arc also. Okay, our next property is we always use the property that angle in a semicircle is always a right angle which measures 90 degrees, right? So, how can we get those 90 degrees in a semicircle? Now we will see. Okay. So, this is the center of the circle. As this is a semicircle, what happens? The semicircle is nothing but an arc, right? So, what happens? This semicircle makes an angle at the center, right? This subtend an angle at the center. What is the angle here? As the semicircle subtend an angle 180 degrees at the center. Yes, I have seen in the last properties. So, this is 180 degrees. We know very well. Okay. Then what happens? The same semicircle makes an angle any other part of the circle. Yes, just related to the previous property you observe. This is the semicircle which is nothing but an arc. So, it follows all properties of arc also. Right. So, this subtend an angle at any other part of the circle. Yes, this is any other part of this, right? This is any other part of the circle and this arc makes an angle here. So, what is the relation? So, the arc may subtend an angle at the center is twice the angle subtended at the any other part of the circle, right? So, which is nothing but we know the angle at the center, that is 180. So, we should have an angle here half of the angle at the center, isn't it? So, what is the half of the angle of 180 degrees? Which is 90 degrees, right? So, that is why this is always a 90 degrees. So, we use this property that angle in a semicircle is always a 90 degrees. Okay. So, this AB, this total is a semicircle and this is an angle in a semicircle. So which is measures always 90 degrees only. Okay. Our next property is, see, we have seen that this arc subtend an angle at the center is twice the angle subtend at the any other part of the circle, isn't it? So if this is any other part of, means this point is on the any other part of the circle, what happens? We have to join the end point of the arcs with the point we have selected. Yes, so their angle forms, and this is with the other part of the arc, that is B. Yes, now see, if this is theta, what happens? This is 2 theta. Okay, so you observe, if I take this point here, what happens? See, I am joining this A and with B. Now here also an angle forms. What is the angle here? See, this is an angle theta we have considered. Whether this angle is also equal to theta or not. See, now you observe the relation between this angle and this angle. The same relation follows as like this, right? Because this is also any other part of the circle and this angle is makes by the same arc. That is why here also the relation must be like the angle at the center is always twice the angle at any other part of the circle. Yes. So if this is 2 theta, what should be here? This is theta only. See, if I consider the point here, what happens? I can join this also. Yes. This is also an angle theta. And if I consider point here, this is also an angle theta. See, if you consider any point on any other part of the circle, the angles are always equal. Yes, because the same relation follows with any point on the other part of the circle, isn't it? So that is why these all angles are equal. If this is P, Q, R, S, yes, these all angles are equal. What is a sector? So, a part of a circular region is called a sector. So, this is in simple words. So, what is the difference between arc and sector? You see, arc is nothing but part of a circle. Means, what is a circle? Circle is nothing but a boundary line, right? So, if that part of a circle, we call it as an arc. So, what is sector? It is a part of a circular region. Circular region is nothing but a circle along with interior. Means if you shade all the interior of this total along with the circle and interior region, we call it as a circular region. So if you take a part of that circular region, if you take a part of a circular region, and this we call it as a sector of a circle. So in other definition, see, sector is nothing but it is bounded by an arc A. If this is an AB arc, it is bounded by an arc and the radii of that circle. Means these two are radii of the circle, right? Yes, this a part of a circular region bounded by a arc and the two radii of a circle. Then we call this part as a sector. Yes. So this ACB is a sector of a circle. Okay. So okay, if this AB and if we consider the minor arc AB, if the sector is formed by minor arc, then we call that sector as a minor sector. Okay. If this sector is formed by major arc is what? If APB is a major arc and this is the sector formed by major arc APB. That is why we call this sector as a major sector. See, this region is major sector. Okay. This region is minor sector. Yes, this region is major sector, this region is minor sector, because this sector is formed by minor earth, this sector is formed by major earth. Okay. See, this is a sector, right? So, what do we call this angle? If an angle of a sector is formed by arc of a sector. See, this angle is formed by arc of a sector, right? What is the arc of a sector? This AB, we call it as a arc of a sector. If an arc of a sector subtend an angle at the center, then we call this angle as a sector angle. So this we call it as a sector angle. So arc of a sector subtends an angle at the center. So this angle we call it as a sector angle. Okay. Sector angle of a minor sector. And this angle is a sector angle of major sector. Okay. So our next definition is segment of a circle. So what is a segment of a circle? Segment of a circle is nothing but a region which is bounded by an arc of a circle and any chord of a circle. See, if this is a circle, let us consider this is an arc AB. Okay, so this is the one arc AB, and we have to consider one chord which is joining the same endpoints of the arc. See, if you join this, means it is a chord of a circle, right? It is joining any two points on the circle, which we call it as a chord of a circle, right? So this is a chord of a circle and this is an arc of a circle. So the region bounded by, this is the region bounded by an arc of a circle and chord of a circle. We call it as a segment of a circle. Okay. So this is also one segment, isn't it? Because this is bounded by an arc APB arc and the chord AB. That is why we call this region as a segment of a circle. So this is also one segment and this is also one segment. Okay. And see, if this segment is bounded by a minor arc and a chord, then we call this segment as a minor segment. Yes. And if the segment is bounded by a major arc, then we call this segment as a major segment. We can also define the segment in another major segment and minor segment in another words, which is, see, if we locate the center of a circle, if the segment consists center of the circle, the segment is nothing but the entire region, right? Circular region, a part of a circular region. This is also, but it must be bounded by an arc and a chord. Yes, if that segment contains center of the circle, then we call that segment as a major segment. If a segment doesn't contain the center of the circle, then we call that segment as a minor segment. Okay. And we will see one property of a segment. So you observe the property is this arc AB makes an angle at any other part of the circle. We have seen that the angles made by the same arc are all are equal, which is nothing but theta, theta, so theta, theta. So this we define as angles in the same segment. So you see this APB is one segment, right? This APB is one segment. In the same segment, these are angles in the same segment. That is why these are all equal. So we can define that property as a angles in the same segment are always equal. So if you take this segment also, means these are the angles made by the major arc. Yes. And these are also angles in the same segment, right? But in the minor segment, whatever may be the segment, the angles in the same segments are always equal. So these all alphas are equal, these are all thetas are also equal. Okay, these are angles in the same segment which are in the major segments, right? So always the angle in the major segment is always acute angle, because this angle is always less than 90 degrees, right? That is why the angle in the major segment is the major segment. The angle in the major segment is always acute, which is less than 90 degrees. The angle in the minor segment, this angle in the minor segment is always obtuse, which is greater than 90 degrees. Yes. See, our next property is, this is a chord AB. It subtends an angle in the major segment is P, right? And if the same chord subtends an angle at the in the minor segment, which is nothing but if this is Q, so we should know the relation between this P and Q. So these two angles are always supplementary. Means the sum of two angles always equal to 180 degrees. If we know one angle, we can find out the other angle. Means these are the angles in the alternative segments. Yes, this is a major segment, this is a minor segment. These are the angles subtended by the same chord, this AB chord only. So the angles are subtended by the same chord in the alternative segments are always supplementary to each other, which is nothing but angle P plus angle Q is equal to 180 degrees. Okay, we can observe this quadrilateral APBQ is a quadrilateral, right? See, you observe this APBQ is a quadrilateral. As all the vertices of a quadrilateral on the same circle, we can call this quadrilateral as a cyclic quadrilateral, isn't it? So this APBQ is a cyclic quadrilateral. We have completed some of the definitions in the circle, and we will discuss circles and tangents in the next video. Thank you.